For a sport such as a marathon, you will be at sub-maximal intensity and the duration is very long. The dominant energy system used for this will be the aerobic system. This system produces the most energy, producing around 38 ATP. The process starts with the glycolysis system, which is the same as the lactic acid system, however it doesn't produce lactic acid. The molecules will break down into the Krebs steps of the system. This will move into the Krebs cycle and then the electron transport chain. This system is very complicated, that is why it takes around 4 minutes to start to make a difference. The system releases many waste products such as water, carbon dioxide and heat, where the carbon dioxide is produced in the Krebs cycle and the water is mainly produced in the electron transport chain. In a marathon, your muscles will be working for hours, therefore the carbon dioxide will be getting produced multiple times. This will increase your breathing rate as more carbon dioxide needs to leave the body. This may cause discomfort as there will be a misbalance in expiration and inspiration. This could worsen your performance in a marathon. The production of heat in the muscles will affect the volume of oxygen that is getting given to the muscles, as the blood would redirect some of the blood to the skin to cool you down. In this aerobic system, you can train your body to burn fuels in order to save glycogen stores. For example, in a marathon, you can try and burn down fats instead of perhaps carbohydrates that contain glycogen. This is very helpful as types of fats such as adipose tissue contains over 80,000 calories of energy. Glycogen is needed for lactic acid, therefore more ATP can be made there. The respiratory exchange ratio is a good way to measure how much carbohydrates or fats you're using. To calculate it, you would divide the carbon dioxide released by the oxygen consumed. For example, if your RER is 1, then you'll be using 100% carbohydrates. This would mean you are working extremely hard and you're not saving any oxygen. If your RER is 0.82, then you are using around 62% fat and 38% carbohydrates, meaning you have saved oxygen, therefore your performance will be improved. This is shown in the table. On the graph on the right, it shows the glycogen depletion in 3 different types of exercise. At low intensity high duration, your glycogen stores would be very high as your muscles wouldn't be working as hard, so not as much glycogen would be used. This means as there is more glycogen, there is more energy to be released, making a runner fatigue slower. In moderate intensity, the glycogen store runs out quickly as your muscles are working a lot harder, so more glycogen will be needed to be broken down, so it deplete quicker. Same goes for the high intensity where your muscles are working even harder. In your neuromuscular system, there are 5 main ways for your muscles to receive an impulse properly and will cause your fatigue slower. The first way is the reduction of calcium ions. Calcium is hugely significant for the impulse from the brain to reach the muscle to tell it to contract. This is because there is a blockage for the actin binding site to connect the troponin, where the myosin will connect to the actin, causing the sliding filament theory. The calcium will knock the troponin out of the way and there will be a cross bridge where the impulse can be able to travel to the muscle. Therefore, if there is less calcium available, then there will be more blockages, meaning the impulse may not be able to reach its destination and the muscle may not contract. Another problem could be the amount of sodium-potassium ions in the axon of the neurons. At rest, on the outside of the axon there are sodium ions and on the inside there are potassium ions. This is ready for an impulse to travel through it. When the impulse does travel through it, the sodium and potassium ions will swap positions. This is called depolarization. After the impulse has gone through, the ions will then return back to its position, where this is called repolarization. In exercise there will be depletion of it, and when the process is happening, the impulses will be coming faster and the membrane won't be able to repolarize and it may not be ready to receive the next impulse. Also at the neuromuscular junction there is acetylcholine. This has a job of transferring the impulse across the synapse towards the muscle. There is also chlorin esterase. This is an enzyme and it will break down the acetylcholine, or known as ACH. This will reset the ACH and prepare it for the next impulse to come. Therefore, If there is less ACH, then there won't be a contraction, as there is enough or not enough for the impulse to be taken over the synapse. If there is less cholesterase, then the ACH may not be ready to collect the impulse. This can cause fatigue, and the muscles will not be getting a sufficient contraction as there is no impulse to contract. Finally, there is a built-up amount of lactic acid. This contains hydrogen ions. The hydrogen ions is very acidic, and this can affect the velocity and force of the contraction. As a result, this shows that the neuromuscular system it affects on the fatigue of the body, as the impulse is being sent can cause fatigue as it is not efficiently sent. This would affect an athlete's performance, as it could cause fatigue a lot quicker and make them finish in a worse position. There are ways you can improve your performance, and one way is glucose ingestion. This is where you can drink energy drinks or take energy gels to increase your glucose in your body, which will release more energy, causing slower fatigue. Another way is glycogen loading, or known as carbo loading. This is where you maximize your glycogen stores by not eating carbohydrates for a while, then eating loads of it the night before. This makes sure you have the highest levels of glycogen, which releases more energy. Lastly, there is pre-cooling. This will lower your body temperature, therefore when heat gets produced in the muscles, this will not affect the athlete as badly.